Hi guys, my name is Roya Naimi and I'm a senior statistics major here at UCLA. And today I'm going to give you a lesson about the normal distribution and some of the properties that it has and the theorems that you can use for the normal distribution. So in statistics, our main goal is kind of to predict things and figure out, the probability of certain things happening. Like how likely is it that this will happen? What are the chances that this will happen? And normally we're making these assumptions based on the population. We want to make it based on the population, but because we don't have access to the entire population, we end up sampling from the population. And so when you sample, it can follow a bunch of different distributions. But the one that you want your sample to follow, or that eventually most samples will follow, is the normal distribution. So there's a theorem called the central limit theorem. Or the CLT for short. And basically what the central limit theorem is stating is that if you have a large enough sample size, the mean of your sample will follow approximately the mean of the population. Or in other words, if your sample size is large enough, if it's over 20 specifically, then your sample is going to follow the normal distribution. And this means that now it follows all the properties of the normal distribution, which is really useful when you're calculating probabilities and things like that from your sample. So that's the central limit theorem. I'll write it really quickly here in notation. So it's the idea that X bar follows mu, which is the population mean, and S, which is the standard deviation of the sample, follows sigma, which is the population standard deviation. So yeah, central limit theorem, if you have a sample that you can apply this theorem to, and then you can say that your sample does follow approximately normal distribution, you can also apply something called the empirical rule. The empirical rule, which is something really handy about the normal distribution. So it basically lets you, when you have the mean and the standard deviation, it lets you know where you fall in the population, what percentage of the population you're falling into. So I'm just going to draw a normal curve here. Okay. And from this normal curve, we know that right in the middle, blue, right in the middle is where the mean would fall. And then if you go one standard deviation over, so that just means one amount of units from both sides of the mean. So right here and right here, this will be one standard deviation over. So plus one on this side in the positive units, and then subtracting one standard deviation on this side. Everything within this chunk of values, that's going to be 68% of your data. So all of this is where 68% of your data is going to fall. Then if you go two standard deviations over, so you already went one, go the same amount for the second one. So it's about that much. All right, so this is now minus an additional one from here, but in total minus 2. Now, the empirical rule also says that everything now from here to here, this is going to be 95% of your data points are going to fall within this range of values. So we could do So from here to here, that's going to be 95%. And then lastly, if you go 3 standard deviations over, it's essentially all of your data is within that range. It's around 98.6, something like that, very close to 100%. It's very rare to have data that is more than 3 standard deviations away from your mean. So that'll be our last one, right here and right here. So this is +3 minus 3. And yeah, that is going to be everything in between these two. That's 98.6%. So this is useful to know because if your sample does follow the central limit theorem, meaning that it's approximately a normal distribution, then you can apply this rule to it and figure out where your data kind of falls.